Welcome to video 12.2. Today we're going to be talking about combinations and the binomial theorem. So our objectives for today are to use combinations to count the number of ways an event can happen. And then tomorrow in class we'll talk about using the binomial theorem. In 12.1 we looked at the permutations of objects. In 12.2 we want to talk about the combinations of objects. So combination is a selection of R objects from a group of N objects where the order is not important. And the formula we're going to use to figure out the number of combinations is this N choose R equation, which looks similar to the one from 12.1, but it's a little different. So for example, the number of combinations of two objects taken from a group of 5, we say it 5 choose 2. This will be the terminology that we use in this section. And then we have our numbers and our factorial signs as well that we use for our equation. In this example, we're going to use a standard 52 card deck to find combinations. So a standard deck of 52 playing cards has 4 suits with 13 different cards in each suit. If the order in which the cards are dealt is not important, how many different 5-card hands are possible? Well, in this problem, the setup is we have 52 cards and we have to choose 5 of them. So if we plug that into the equation of N choose R, this will be our N, this will be our R, and then we plug that in and we get 52 factorial divided by N minus R, which is 47 factorial, times 5 factorial. Then we evaluate this in our calculator. We get 2,598,960 combinations. There will be instances when we need to find the number of ways both an event A and an event B can occur. For those scenarios, you always multiply. But when you want to find the number of ways that an event A or an event B can occur, you add instead. In this problem, we're going to learn the differences of multiplying and adding combinations. So for our first problem, we have to choose exactly 2 vegetarian ingredients and 1 meat ingredient. So there are 6 options on the vegetarian side, and of those we have to choose 2 of them. There are 4 meat combinations, so we have to choose 1 of them. So we have 6 choose 2 times 4 choose 1. And we do this in our calculators, we end up with about 60. Now for part B, it's a little different. Here we can afford at most 3 ingredients in our omelet. So we can possibly have an omelet with no ingredients, an omelet with 1 ingredient, an omelet with 2, and an omelet with 3. So there's 4 possible opportunities. So if we have 10 ingredients, we can choose 0. Of those 10, we can also choose 1. We could choose 2. We could choose 3. So we're adding all these together. And when we do that, we get 176. There will be counting problems that involve phrases such as at least or at most. And when we're solving these counting problems, usually it's better to subtract the possibilities you do not want from the total number of possibilities, as opposed to counting every single option for a possibility. In this example, we're going to look at the difference between subtracting and adding. So here we have this theater that's staging a series of 12 different plays. You want to attend at least 3 of the plays, so how many different combinations of plays can you attend? Well, technically, there are 12 different plays, and you want to attend at least 3 of the plays. So you can do 12 choosing 3, and you can do this for every number all the way down till you get to 12. Now, in this scenario, we're adding all of these, but sometimes it's easier to subtract the possibilities you do not want from the total number of possibilities. So let's look at subtracting. when we subtract, we want to subtract total possibilities from options that we don't want. So options we don't want. So total possibilities is if you're going to this theater, there are 12 different plays. And at each play you can either go or not go. So there's two options. Now since there's 12 different plays, there's 12 combinations of those two. So this number is 4,096. So what are the options we don't want? Well, we want to go to at least 3 of the plays. So we don't want to do is we don't want to choose none of the plays. We don't want to choose one play. We don't want to choose 2 plays. These are all the options that we don't want in this scenario. So we combine this. We have 4,096 minus 1 plus 12 plus 66. And we end up with 4,017. Okay, we're going to stop here. We're going to cover the binomial theorem tomorrow. Once again, I hope this was helpful, and thank you. Take care.